Pluto made them come up and down. Pluto's circle crosses that of each other planet. Pluto, the astounding little planet at the external extents of our nearby planetary gathering, is running up further in the field of space innovation. Continuous surveys suggest a possible encounter with Neptune, raising concerns among scientists and space fans. Renowned figures like Neil deGrasse Tyson and Michio Kaku have sounded alarms about the consequences of this galactic event. But how did Pluto end up on a trajectory that intersects with its neighboring planet, and what could this celestial battle mean for life on Earth? Join us as we explore how something gigantic just collided with Neptune and how scientists have been left confounded by this incredible anomaly. Pluto, once hailed as an irrefutable planet, went through a transformation in its status, being renamed as a dwarf planet due to its impressive orbit. Despite this demotion, Pluto still charms and fascinates the cosmic community. Later assumptions from prominent analysts like Neil deGrasse Tyson and Michio Kaku have raised concerns about Pluto's orbit potentially meeting with Neptune, indicating an approaching series of collisions among the celestial bodies, which could have significant repercussions for Earth. Pluto's journey around the Sun stands out because of its unique features within our planetary system. Its orbit is surprisingly elongated, crossing an exquisite 248 years since its discovery in 1930. Pluto still hasn't finished a full revolution around the Sun. Adding to its distinctiveness is the particularly elongated shape of its orbit, a departure from the more round orbits followed by the major planets. Additionally, Pluto's orbit deviates by 17 degrees from the ecliptic plane, giving its path a steeper angle compared to other planets. The combination of Pluto's orbit and its tilted path presents layers of complexity to its orbital design. One significant point is its occasional intersection with Neptune's orbit. For about 20 years during each cycle, Pluto ventures closer to the Sun than Neptune, contradicting expectations based on their different positions within the nearby planetary system. It's fascinating to note that Pluto's orbit is not perfect but rather elliptical, more oval in shape. This interesting orbit results in significant variations in Pluto's distance from the Sun during its journey. At its closest approach, Pluto comes within 30 astronomical units, AU, of the Sun, while at its farthest, it reaches more than 49 Australian dollars away, twice the distance of Neptune from the Sun. Moreover, Pluto's orbit is tilted at a large angle compared to the orbits of the major planets in our solar system. This tilt not only adds to the complexity of its path but also plays a significant role in its interactions with other celestial bodies, especially Neptune. When Pluto passes through Neptune's orbit, their gravitational fields influence each other, adjusting their paths over time. The intricate dance between Pluto and Neptune highlights the dynamic nature of our planetary system. While Pluto was once considered a lonely object in the outer reaches, its close encounters with Neptune emphasize the interconnectedness of celestial bodies, each exerting gravitational forces that shape the orbits of others. In recent years, advancements in observational technology have allowed space scientists to track Pluto's movements with exceptional precision. This has led to a deeper understanding of its orbit and the potential implications for the stability of the outer solar system. Although the chance of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely dismissed, prompting increased scrutiny by the scientific community. Despite its small size and remote location, Pluto continues to captivate the attention and curiosity of researchers and enthusiasts alike. The question arises, why hasn't there been a collision between Pluto and Neptune? The answer lies in the gravitational pull from other planets. Astronomers began analyzing Pluto's path shortly after its discovery, and its orbit perplexed them. Unlike most planets, which remain close to the same plane as they orbit the Sun, called the ecliptic plane, Pluto stands out with its steep angle and oval-shaped orbit. The mystery deepened when they realized that Pluto's orbit crosses that of Neptune. Despite these complexities, Pluto's orbit remains stable, demonstrating the intricate mechanics of space. Understanding Pluto's orbit is crucial, especially when considering whether it could eventually collide with Neptune. This knowledge helps us better understand how our entire solar system works. Pluto's orbit teaches us that even orbits that seem perilous can stabilize due to gravity and the way objects move in space. Continuing to study and analyze these phenomena is essential for expanding our knowledge of the universe and our place within it. When we explore space, we find that things can be strange, and Pluto's orbit is a perfect example of that. Pluto's orbit is unlike that of the other planets. It is more oval-shaped, meaning it is not a perfect circle. At times, it even comes closer to the Sun than Neptune does. This makes things intriguing, as Neptune is also moving along its path. There is a small chance that Pluto and Neptune could collide, but despite this, Pluto's extraordinary orbit manages to avoid Neptune most of the time. This is because of something called gravitational forces. Gravity is like an invisible force that pulls objects toward each other. So even though Pluto and Neptune may seem to be on a collision course, their orbits are carefully arranged, guided by the pull of gravity. Pluto's orbit shows us that space is full of surprises. What seems chaotic at first glance can be a delicate balance of forces. By studying Pluto's orbit, scientists gain insights into the complex mechanics of our solar system. Ongoing observation and investigation are essential for deepening our understanding of the universe and our place in it. Imagine if Pluto and Neptune did collide. It would be a cosmic event, sending shockwaves through our understanding of the solar system. While we've made progress in understanding space, current events show that we still have a long way to go. Focusing on how large planets affect Pluto's orbit gives us valuable clues about how the entire solar system functions. It teaches us that the positions and movements of the planets can change the paths of other objects in space. Despite the complexity of space, some top researchers are concerned that Pluto might collide with Neptune. This makes them wonder why such an event could happen, even though it seems unlikely. Neil deGrasse Tyson, a famous space scientist, has raised questions about Pluto. He believes that renaming Pluto as a dwarf planet, instead of a large one like Earth, is a step forward. He thinks we are constantly learning new things about how things move in space. Tyson sees Pluto's unusual orbit as a sign that there's still much we don't know. He believes that the mysteries of space are incredibly exciting and that big events like Pluto's reclassification get people involved in astronomy. Tyson wants to help people understand the cool and sometimes strange aspects of how space works. He thinks it's important to discuss how space mechanics can surprise us. Tyson works with other scientists to warn people about the potential dangers of Pluto's orbit. Focusing on Pluto and the possibility that it could eventually collide with Neptune makes him concerned. He says that this could cause significant issues for our entire solar system. A crash between Pluto and Neptune could release a lot of energy and might break Pluto apart. Pieces from the crash could fly around space and hit other planets and moons. Neptune might also feel the impact, affecting its movement. Renowned theoretical physicist Michio Kaku, known for his contributions to string theory and science communication, offers an interesting perspective on space exploration. He firmly believes that understanding the future of space travel and the relationship between celestial mechanics and theoretical physics can be gathered by studying features like Pluto's orbit. Kaku sees Pluto's orbit as a window into the future of space exploration. By grasping the complex gravitational interactions and orbital dynamics of celestial bodies like Pluto, we can improve future space missions, making navigation through the solar system safer, predicting potential hazards, and planning missions to distant corners of our vast universe. Kaku emphasizes the deep connection between celestial mechanics and theoretical physics, highlighting that the movements and interactions of planets, like the gravitational dance between Pluto and Neptune, are crucial to understanding space. Neptune is established in essential standards of physics. Kaku's work in theoretical physics, specifically string theory, seeks to unravel these principles at their core. He suggests that focusing on the complexities of celestial mechanics, like Pluto's orbit, can provide insights into the key laws of the universe. Kaku has also pondered the potential impact of massive bodies, referring to them in his speculations about the universe. An event like a collision between Pluto and Neptune, while significant in astronomy, could offer a unique observational opportunity, potentially contributing to our understanding of string theory. String theory, which replaces point-like particles with one-dimensional strings, aims to explain the fundamental forces and matter in the universe. Such a collision could create extreme states of energy and gravity, revealing insights into the behavior of fundamental particles and forces under extreme conditions. Additionally, the gravitational waves produced by such an impact could provide valuable data for testing string theory's predictions regarding gravity and spacetime. While the direct impact on Earth would be minimal due to our distance from the outer planetary system, the scientific implications could be profound. Understanding events like these could enhance our interest in the fundamental nature of the universe, as described by string theory and other areas of theoretical physics. Pluto's extraordinary qualities, influenced by the gravitational forces of nearby planets, especially Neptune, highlight the complex and dynamic nature of space. Yet the universe holds many secrets, and the three-body problem is only one of them. Scientists expect other potential disasters, underscoring the ongoing quest for knowledge and exploration in the vast universe. Although highly improbable, there is still a slight chance of planets colliding in space. This could occur because the paths of planets are affected by various factors, such as gravity from other planets, a phenomenon known as the three-body problem. In systems like the TRAPPIST-1 system, where there are 7 Earth-sized planets, the gravitational forces create a sort of dance in how the planets move, called orbital resonances. Over time, these resonances can make a planet's path less stable and could potentially lead to collisions. However, in systems like TRAPPIST-1, while the planets are numerous, impacts are not occurring at present. Scientists monitor these systems to understand how planets affect each other's paths, especially when they get close. This helps us understand how planets move through space. Sometimes, there are rogue planets that do not orbit a star and float aimlessly. These planets may have been part of a star system but got ejected due to factors like gravity or when another star came too close. Over time, these rogue planets can travel vast distances and might encounter other star systems. However, because space is so vast, the likelihood of them colliding with another planet is extremely low. Rogue planets are rare compared to the number of stars and planets with stable orbits, so impacts are even less likely. When galaxies merge, it can disrupt the orbits of the star systems within them. While planets are unlikely to directly collide during these massive events, gravitational interactions can alter the movement of stars and planets. Occasionally, planets may be flung into space, becoming rogue worlds. Other times, they might collide with each other or their host stars. These disturbances can also lead to the formation of new celestial bodies or new stars. The late heavy bombardment theory suggests that around 4 billion years ago, there was a period of increased impacts from comets and asteroids. This bombardment is believed to have occurred because the outer planets, like Jupiter and Saturn, were moving around a lot, which disturbed the orbits of many smaller objects in space. As a result, these smaller objects were thrown onto erratic paths, many of them ending up in the inner part of our solar system. This caused a significant increase in impacts on planets like Earth. While these impacts did not involve planets colliding directly, they demonstrated that gravity could make dramatic changes in how objects move through space. This bombardment shaped the surfaces and histories of planets in our solar system. It might have even brought water and organic materials to Earth, helping to shape our planet.